Yesterday, you may have noticed a little bit of activity from the northwestern limb. A series of coronal mass ejections have occurred. You may be wondering if they're earthly directed. So are we. So join us for today's daily space weather video, and thanks for tuning in to the Smash News Network, least busted name in news. We're only bringing you the most comprehensive daily space weather and detailed imagery of the closest star you'll find anywhere in the known universe. So thanks for stargazing with us. Let's take a look at some additional imagery here of the exciting events. We also saw some prominentiary activity and a little bit of flaring from the southwestern limb, a prime example of how you don't need to see lots of sunspots or even solar flares to see coronal mass ejections. These are three separate phenomena. There's the full disk view. That's 304 plus 171 angstroms. Very low number of sunspots. We've seen another precipitous decrease in the radio flux as forecast. So there's 304 plus 195 angstroms. And by the way, we streamed this yesterday, so if you didn't see it, it was streaming on Twitch. You can still find it on the Twitch channel at twitch.tv/smashomash. Started streaming just in time to catch the full CME there, as well as some splashdown. Spectacular imagery there from the GO 16 SUVI. Also, some additional events occurred later. Let's see. Something was going on down here in the southwestern limb as well. You can see some flaring happening there and at a great prominence. And those videos remain publicly visible on the Twitch channel. And let's take a look at sunspots. Declining number of sunspots. You can expect another downtick in sunspot number today. How low will it go? Let us know in the comments what you think. Here's your colorized magnetogram. That imagery is yesterday plus today. This is also yesterday plus today. And let's take a brief moment to look at volcanic eruptions. So here's what's currently going off. Shivaluch is exploding and producing a 15,000-foot ash plume over Kamchatka. That's a flight level 150. Abiko. Volcanic ash is not identifiable in satellite imagery. Don't assume it's not erupting. Semaru, flight level 150, also at Semaru. It's a 15,000-foot plume of volcanic ash from the East Javan volcano. Popocatépetl exploding, flight level 220 over central Mexico, 22,000-foot ash plume. Santiaguito, not sure if it's erupting or not. Volcanic ash not seen in satellite. It could be cloudy and erupting. Fuego exploding, flight level 150. Nevado de Ruiz in Colombia exploding, flight level 200. Sangay in Ecuador exploding, flight level 220, 22,000-foot ash plume. And not sure about Sabancaya. Please do not pole vault the caldera. By the way, today's featured product is the Croissant Earth Society. So we remind our viewers regularly that Earth is actually croissant-shaped. We're not believing what Neil deGrasse Tyson or NASA or Ptolemy says about the shape of the planet. The shape is clearly the shape of the French breakfast pastry, the croissant. And if you're still believing NASA's lies, please stop being such a sheeple. Realize that civilization is ending. We are in a grand solar minimum, and we hope your bunker is the exact right depth. April Fools. Hopefully you're not April Fools who are believing a bunch of nonsense on YouTube. That space is very scary, the sun is very dangerous, and the only thing more dangerous and scary than the sun is the galaxy. Complete and utter cosmology nonsense. So check out the merch. You can find links below the video. If you want to support the channel, consider becoming a member of the Smash Team at smashomash.com/Smash Team. It's the official subscription services site of the Smash News Network, least busted name in news. So help support the channel, especially if you like these videos, prefer to see them remain in existence, publicly visible, and free for all to view. Consider becoming a member of the Smash Team, especially at the gold or silver Smash Team level. If you'd like a complimentary email address, join at the gold level. If you'd like some complimentary merch, join at the gold annual paid up subscription level. Links below the video as well as on the homepage. Also links on the Smash Team page to the Hemp Lucid shop. So if you haven't checked that out, check out the Hemp Lucid shop. Pick up your Hemp Lucid products via our link. All kinds of testimonials there from various experts. You could consider being an expert as well. So check them out. Links below the video and on the homepage to the Hemp Lucid shop. Don't forget to enter the promo code SMASHOMASH to save some cash on your checkout. The promo code SMASHOMASH will save you some dough, so make sure you enter that when you're purchasing your CBDs or mushroom gummies or perhaps body balms from Hemp Lucid. Again, links below the video and on the homepage at smashomash.com. So welcome to the Neo Renaissance. Congratulations on realizing this channel exists. If you'd like to see it continue to exist, help support the channel by clicking on links, visiting us on social media, pressing share, leaving comments, etc. And let's talk about earthquake droughts. So earthquake droughts, we talk about them regularly on the channel because, well, when there's a period of time when you don't have a 7 magnitude earthquake, it's called an earthquake drought. For example, the year 2015 started out with a lengthy earthquake drought. No 7 magnitude quakes occurred in 2015 until just before April 1st. So these are the historic earthquake graphs. There's 2016, there's 2017, which had a very lengthy earthquake drought. 2018 had a lengthy earthquake drought. There's 2020, there's 2021, there's 2022. Here's the year to date. So a bit of an earthquake drought going on here in the past 90 days. Remember, earthquake droughts end with large earthquakes. And let's talk about an earthquake near Palomar Observatory under Palomar Mountain. We don't usually talk about 4 magnitude quakes. This one was only a 4.2, and the point is that any earthquake can be a foreshock. So early this morning at 1:16 Universal Time, there was a 4.2 under Palomar Mountain. Just to reiterate, any earthquake can be a foreshock. So let's scroll up the list here. We'll cite earthquakes above a 5 magnitude, as we generally do on the videos. So quite a few earthquakes here occurring around the Pacific Rim, none of a large size. I think the largest was perhaps this 5.6 at the Southeast Indian Ridge. That one not around the Pacific Rim at all. And did we have any other quakes above a 5 magnitude? There's at least one more, a 5.0 near Japan. That was at 9:41 this morning. Just to reiterate a third time, any earthquake can be a foreshock. So let's get back to space here, and we hope you're very spaced out. I'm sure you are quite a spaced out viewer. And thanks to our new subscribers, those who've been leaving comments, discovering the channel, etc., congratulations. We have trouble finding our own videos regularly on YouTube. That's the past 24 hours and 304 plus 171 angstroms from the Gozar. Here we've swapped out the 171 angstroms for 131 angstroms. And those two wavelengths are great at showing active regions. Where you see bright blue, that's where there's a lot of that species of ionized iron. And when you see a lot of bright red, that's where you've got a lot of ionized helium. That's the 304 angstroms wavelength. The iron is the 131 angstroms wavelength. And the 10.7 centimeter radio flux is now all the way down at 129 solar flux units. If you're wondering what a solar flux unit is, it's radio flux density at 10,000 joules. So, in other words, 10,000 joules of radio flux density. If you have a 100 radio flux, you've got a 1 million joules of radio flux density. Anyway, there is the 1-year graph to put all of that in context. The black line is the radio flux. The red line is a sunspot number, which is also dipping way down today. Will we get to a 0 sunspot day? Let us know in the comments what you think about that. And let's take a look at the Space Weather Enthusiast dashboard. So NOAA not forecasting any coronal mass ejection impacts, at least not yet. It could be too early to tell. But at the moment, no space weather storms in the forecast. We are still seeing a high-speed coronal hole wind stream. It has been subsiding. I think we're on the very tail end of this. Here's Earth's magnetic moment from space for the past 4 hours. This imagery is our Geospace Magnetosphere movie, which depicts magnetohydrodynamic pressure, the units of which are nanopascals. You can see most of the pressure there is on the magnetotail side. The sun would be off to your left from this imagery, and that is Earth's plasma environment attempting to reach static equilibrium. We'll also show Earth's magnetic moment from the ground. Geospace delta B is changes to Earth's B field. The units depicted in this imagery are nanotesla, and that is also the last 4 hours. Earth's magnetic moment from the ground. We showed you it from space. Here it is from the ground, and we are in geomagnetically calm conditions, which will persist for the foreseeable future. There's your planetary K index, a general global average of geomagnetism, currently at KP2. KP2 is the current planetary K index. And let's go out to Lagrangian point 1, where the ACE and Discover make their measurements of the solar wind. Current conditions are only about 2.5 protons per cubic centimeter for the solar wind density. Solar wind speed, 564 kilometers per second. Again, this looks like it might be the tail end of the coronal hole high-speed stream. If you've got other ideas, let us know in the comments, and thanks for leaving a comment. One Audio, good morning to you as well, Mr. La Follette. So here are the GOES magnetometers. These are measuring Earth's magnetic field from their geosynchronous near equatorial orbits. Once again, back into a pretty tight range here. Pretty low highs and pretty high lows for the past 24 hours at least. Again, it looks like the subsiding of a coronal hole wind stream is in effect now. Next, looking at the top view ecliptic plane field plot, this is the sun's heliospheric current sheet. As the sun spews out plasma, the plasma gets oriented to one polar field or the other. Earth remains in a south pole-oriented current sheet depicted here in red, and we expect to be there also tomorrow, barring some sudden changes in the east. Next, our line of sight field plot. Here the sun's B field is depicted in blue, south solar polar field in red facing the Earth, north solar polar field in green facing away from the Earth, and let's move to coronal holes. We do have some North Pole-oriented coronal holes down here in the southeastern limb, kind of moving around a little bit. You might see some motion happening there, some effects on the B field, and some motion of those coronal holes. You can see some North Pole magnetism up here also, an indication that there is still a long way to go to get to solar maximum. So we're going to show you the 211 angstroms wavelength here. Just give that a minute to initialize. Let's bring up the last image. So we've got some North Pole coronal holes down here, and most of the rest are South Pole. So these will get a little more clear in the next couple of days. They're not particularly visible yet. All of the rest of these are South Pole oriented, with the exception of this little bit of North Pole magnetism up here. And that's got to leave the North Heliographic Pole before we can say we're at anywhere near solar maximum. Anyway, that's what's going on in 211 angstroms from SDO, which brings us to sunspots. Getting into a low number of sunspots here. There is at least one or two named groups that ought to get names. I believe it's this one down here. We should have 3268 named today. And there might be two or three new named groups here, but they're pretty small at the moment. At least they were when we did show prep. Keep in mind the magnetic environment can change with basically no warning. So here's some more imagery. SDO is back on HelioViewer now. At least parts of SDO, the HMI instrument is. So let's get rid of the 171 angstroms and zoom in a little bit closer here. So there's at least one sunspot, at least two new name groups. We should have 3268 and 3269 by the end of the day today. But we'll still see a dip in sunspot number because we've got a bunch of large groups setting up here in the northwest. There is still certainly a capability of large flares from especially the northwest. Southwest, a lot less likely now. It's ramping down in its likelihood of producing large flares. There is still a significant possibility of large flares up here in the northwest. So that's what we'll be keeping an eye on today. And when I say eye on, well, pardon the pun. So we did have a recent long-duration flare, but it didn't produce any relativistic particles yet. That's what we're looking at with the GOES proton flux relativistic particles there. And no solar energetic particle events recently occurring. Here's this long-duration flare, the largest flare of the day so far. Peak flux was around 3:30 universal time this morning. It was a C6.78 class flare. Yesterday did feature one M class flare. Just barely into the M range, it looks like. No, maybe not. Looks like a C9.64. Okay. Well, a nearly M class flare. And let's take a look at some wavelengths good at viewing flares. Keep in mind these are not X-rays. This is just extreme ultraviolet light. But 94 angstroms is a great wavelength to view flares. A little bit of flaring on this sunspot also. So again, the most likely place to see large flares today would be up here in the northwest. Here we've added 171 angstroms to our 94 angstroms wavelength. These are 24-hour videos. And we've also got 131 plus 171 angstroms. So quite low levels of activity here. Don't expect it to persist, as solar maximum simply isn't here yet. I don't care what any YouTube channels told you. We just simply aren't at solar maximum yet. Next, just to orient you, we've got a star chart. So this is what's going on over Lehigh Valley. You just press the Now button, and that's what's happening. If you're up before dawn, you might see Saturn. And if you're up after sunset, you might see Jupiter and Mercury there trailing the sun. Mercury getting quite high in the sky here. Jupiter and Mercury there, available to view in the evening sky. And let's do a solar system forecast from this lonely side of the solar system. So this is where things currently are. Let's move this ahead 1 week. Here's where things will be on April 8th. And let's take a look at some coronagraphs, since we've got some spectacular CMEs happening yesterday. Some very, very dense plasma there. You can see ejecting those very bright bits of plasma there. Some great CMEs there showing up on the coronagraph imagery. That's yesterday's imagery. Here are today's images. And additional CMEs have already happened today. So we're going to do some analysis of those by looking at the view from stereo A and the Soho Lasco C3. So we paused this at yesterday at just after 1600 universal time to just slowly try to evaluate each of these coronal mass ejections. So this one is certainly off to the northwest. That is not earthly directed by any means. And as we advance this a little bit further, we'll see a second event there from the same location. So there we are at 2030, and there's 2053 on the stereo A instrument. That's close enough. So that's also not an earthly directed coronal mass ejection. Let's move on into today. Ooh, a bunch of missing data there. So we've got 7 hours of missing data. Let's go to about the first thing this morning as there are additional CMEs happening. So first of all, we've got one there, again, out of the west. That one out of the southwestern limb at about 5 o'clock universal time. That one does not look like it's earthly directed either. Then there's a second one coming out of the south-southeast. Probably also not earthly directed. Now, there is also a stealthy one here that is coming out of the east. That one may have an earth-directed component. Let's take a look at our coronagraphs here to see if there's any limb darkening events. That one was around, let's see, that was at just around midnight. Let's get in a little bit closer here. Let's get a little bit closer than that. Oh, I don't suspect any of those coronal mass ejections are earthly directed. If you've got other ideas, let us know in the comments. And thanks to everybody who's left comments the past days and weeks. We do read them all, even if we are unable to respond to every single comment. Next, looking at filaments. And we've got massive filaments on the Earth-facing portion of the solar disk. The Shaquille O'Neal filament remains intact down here. So that is definitely one to keep an eye on, as if that ejects at the moment, it could be very much earthly directed, and it is a huge, huge filament. Also, this filament up here is quite large. This filament up here has got honorable mention. Filaments, filaments, filaments. And if there's a filament you'd like to name, just don't name this one. It's the Shaquille O'Neal filament. The rest of these are open to be named. So if you want to name them, follow the hashtag #NameThatFilament over on Twitter. Drop us a line. Hit us up on Twitter. We'll name it over there. Not in the YouTube comments. And certainly not in the BitChute comments. All right, here's one more 24-hour video from the GOES-R. That's 304 plus 284 angstroms. We like to provide a holistic ultraviolet view of the closest star. So that's a lot of images. And here's the past couple of hours. Again, there's still certainly the capability of large flares up here. We could even see large flares down here yet. So, I mean, you can see these huge loops of plasma down here. So, yeah. There's still a significant solar flare watch for the possibility of M or maybe even X-class flares right in this little sliver. And that brings us to our bonus features segment. So first thing we'll look at is satellite charging hazards. We've got some internal and some surface charging hazards. The internal ones are over the Western Pacific, Oceania, and the Central Indian Ocean. Surface charging hazards here over the the Eastern Pacific, moving off of Western Mexico there toward the Central Pacific. Those are both minor charging hazards of the surface and internal charging variety. That's electrons building up on the surface of satellites, and this is electrons building up inside of the internal circuitry of satellites. Goes electron flux here kind of high. And let's take a look at the forecast model. That's a 3-day measurements by the GOES-16 and GOES-18 using radiography. There is the forecast model. And I believe I forecasted that pretty close to being on point on yesterday's video. And let's move on to the 1-year graph. There you go. There's the 1-year graph of the electron flux. We're just in sort of an operating range here. Nothing to write home about. And let's take a look at the ionosphere. Here's the raw vibrational frequency of the F layer, which is at about 300 kilometers of altitude. It's the bridge between Earth and space. As we zoom in closer and closer to planet Earth, this is what's shaken. We've certainly got significant anomalies happening here. Check out the anomalogram. That's anomaly in megahertz from the 30-day median. Major equatorial low-frequency anomalies, also some significant persistent low-frequency anomalies over the U.S., the eastern U.S., I might add. That's not ultra-common, that long-standing low-frequency anomaly there. An indication of probably denser plasma there. Now, keep in mind, essentially, high vibration is similar to heating, although you wouldn't experience it as heat if you were there because it's very diffuse. We'll let that play through one more time. And here's your latest image. That's 11:45 universal time on the ionogram, and there's 11:45 universal time anomalygram. Total electron content is next. First, we'll show the total electron content forecast. So, by the way, this stays about a half an hour ahead as this attempts to forecast the total electron content. And let's show the North American total electron content. This is the anomaly from the 10-day average. We're seeing some low electron content anomalies and then some very strange ones here at the end. Check out the last frame. Pretty bizarre. Some high-frequency anomalies here in the Western Atlantic. And some big variations there. From low to high. So that's the anomaly from the 10-day average over North America. And here's just the U.S. and Mexico and Canada. Also the Caribbean. Anyway, some real oddities there. Showing up in the final frame around 2300 universal time. The heck? Around 2330. Looking like old data there. Anyway, let's continue on to show the latest intensitygram and magnetogram. A much less active sun than we saw even just a week ago. Let's see if we still have some new sunspot groups to get named over here. There's at least one. That should get a name today. And besides that, it is a barren disk as far as sunspots go. So it looks like we may only have one new named sunspot group today. And it's quite basic, as it does appear to be an alpha class sunspot group. I only see one umbra there, and it is of South Pole orientation. So one alpha class sunspot group will see the sunspot number dip again today, and probably also the radio flux dip even lower than 129 solar flux units. And that ends our space weather portion. Let's move to the realm of meteorology. Before we do that, take a moment to press like, subscribe, share, etc. Again, congratulations on realizing the channel exists, and a reminder that if you've had trouble finding the channel, we don't blame you. We regularly have trouble finding our own videos on YouTube. Also follow us on Twitter as we approach 400 followers. Will you be our 400th follower on Twitter? We've only been there for over 4 years, and we've only put up nearly 20,000 tweets, daily original content every single day on the platform. I'm sure it's totally not a deboosting algorithmic feature. And no, I don't follow Elon Musk. His tweets are infantile and ridiculous. and his memes are like built by a third grader. Next, we're starting out meteorology here with ocean currents and sea surface temperature anomalies. So, unfortunately, folks, check it out. The Gulf Stream is dead. So, it's going to be a year without a summer in Europe because you can see the Gulf Stream here. It's just not making it to Ireland and Iceland. April Fools, it still is. Europe will have a summer, and the Northern Hemisphere is not going to freeze. At least not this summer. Not with the current situation here. So we do have a mix of quite warm and cold water there, anomalously warm and hot water up the East Coast and in the North Atlantic. And as you can see up here, there are still indeed Gulf Stream currents at Ireland and Iceland. So, so as far as the grand solar minimum goes, and as far as, oh no, Ice Age or Snowball Earth scenario happening via the mechanism of cold water shutting down the North Atlantic oscillation, it's just not happening. Anyway, let's just show the rest of the planet here since we're on sea surface temperature anomaly and currents. Here's what's going on in the Southern Ocean. How about the Indian Ocean? Let's don't forget the Pacific, Earth's largest surface heat sink and largest body of water. Those things are related, if you're wondering. And there is the Atlantic. And let's don't forget the Arctic Ocean. Anyway, we'll switch to winds as we do normally on the videos. So these are the surface winds of the eastern world, Oceania, and the Far East. Here are the jet streams, represented by the 250 hectopascal winds. Jet streams of the Americas, depicted here. And if you're picking only one weather feature to forecast global weather patterns, I recommend the jet stream. Here are surface winds. And it's windy on the east coast of the U.S. as well as in the central U.S. Also, Lake Superior seeing some strong winds. Also, some powerful lows here off the coast of South America and in between the Azores and Newfoundland. Here is the surface wind scenario for the central world, Europe, Africa, and the Middle East, and there are the jet streams. As the sun rises over the Atlantic, we're interested in clouds and fog. So we're looking at the NASA GOES Interactive Weather Satellite Suite's 3.9 nanometer shortwave radiation map. It shows clouds and fog. And let's take a look at weather.gov. So there's your forecasts. We've got some blizzard warnings for Minnesota and Wisconsin. If your location's lit, click your location. Those are too many counties and too many weather warnings for us to go over in this video. If you've got a specific weather forecast that you'd like us to do, let us know in the comments. We'll consider it. Next, our pressure and precipitation forecast for the next 72 hours based on the GFS weather model. Heavy snows there coming to Wyoming. And blizzard conditions striking portions of Minnesota and Wisconsin. Some strong storms also about to kick up once again over East Texas, Oklahoma, and Arkansas. Next, our total accumulated precipitation in inches. That is also the GFS model. We actually heard some thunder here in Lehigh Valley, Pennsylvania this morning. The first I remember hearing for quite a while. I think the first thunder of spring, actually. So you can see some heavy rains there forecasted for Arkansas and Oregon. As many as 4+ inches in some of those locations. Also, we've got total accumulated snow depth in inches. That's a 72-hour GFS model for accumulated snow depth. And it's looking like over 2 feet of snow coming to portions of Oregon. Also, Wyoming, getting some pretty significant snowfall there. And let's continue on to our windy.com map. We're just looking at snow depth here. And of course, that is indeed a lot of snow over the western U.S., also even the north central U.S. Quite a bit of snow up there. And let's take a look at the snow totals, since we're now in the month of April, from Global Cryosphere Watch to see where things stand for Northern Hemisphere snow totals. So the first thing we'll look at here is the snow extent, which has now found itself right back into the normal meaty part of the range, right in the middle of the plus or minus 1 standard deviation there for the 1998 to 2011 averages at least. So snow extent here as normal as it gets, right in the middle. Snow mass balance, not including mountains, also just a little bit above the 1982 to 2012 plus or minus 1 standard deviation range, which is the blue shaded region. So very average as far as that goes. And snow water equivalent, well, really, really high. So if you're downstream from a bunch of snowpack, be prepared for the possibility that if your temperatures suddenly rise, to see epic flooding. So that's what's going on. That is indeed a lot of snow water equivalent. It's, let's see, what is that? Cubic kilometers. You're talking about 500. You're talking about 400 kilometers, 400 cubic kilometers of snow water equivalent above the plus or minus 1 standard deviation range. That is indeed a lot of water encased in snow at the moment. Don't worry, you're not going to see a year without a summer, so it is going to melt, most of it. And here's our NASA GOES lightning mapper. Again, we've got lightning all the way from Louisiana to New England. Little missing data there, it looks like. Let's take a look at a real-time lightning map. And we indeed have some active cells. Looks like north of Athens, there's thunder rolling in for sure. And also west of Montgomery. So those are thunderclaps propagating there. Next time you hear thunder, check it out. I did it just this morning, and I forecasted thunder. Smash staff can corroborate it. I did a countdown, and I was only off by about 1 second. Keep in mind, air density does affect the speed of sound. Anyway, here's your full global map from lightningmaps.org. And let's look at the U.S. Doppler radar. Radar.weather.gov is where we currently are. Let me just press refresh as it doesn't look animated. Radar.weather.gov. There's the full 50 states of ALSA, the allegedly United States of America. And no idea why that's not animated. Oh, because I didn't press the play button. That could be why. All right, so what is up with that? Missing data on the radar? That's weird. Those are ground-based systems, so I don't know what's up with that. Maybe some server outages or something like that. As we look at clouds and fog next, once again, that's a 3.9 nanometer infrared radiation map. And the water vapor is next. So we do have this low right here. And it's over land. It's surrounded by a bunch of dry massive air, but you can indeed see a counterclockwise rotation there. So that's going to take its good old time there, moving to the east, as there's not a lot of impulse behind it, at least not yet. Now this moisture down here, this does have a bit of an impulse because it does have this dry mass of air right here, which is a relative high pressure zone, giving it a little bit of an impulse to the northeast, but this area right here, that's actually a low pressure zone. You can see that counterclockwise rotation. And let's close things out with a recap. There's some of your U.S. Doppler radar data. There's your shortwave radiation showing clouds and fog. And there is your water vapor. And here is me closing this video out. Thanks for tuning in to the Daily Space Weather. Congratulations on realizing the Smash News Network least busted name in news exists. And may that solar wind be at your back. Also, don't forget to visit the links here and here and here.